Okay, my name is John Lightsey. This is going to be auditing open source Perl code for security issues. This is not going to be a comprehensive talk on different specific ways that you can attack Perl code or a systematic way of writing more secure Perl code. This is really a distillation of what I like to do on the weekends, which is, you know, grab other people's Perl code and look for all the vulnerabilities I can find inside of it. So, yeah. So why do I do this? Well, it is very fun. You know, it is a real rush when you take somebody else's web application and find a way to, you know, start from the outside and completely, you know, control what's going on the inside. It's also an excellent learning experience. You see a lot of very bad Perl code and a lot of very good Perl code, and some things that you sort of intuitively think they're going to be very insecure. When you actually go through the code step by step trying to figure out how you would exploit it, you find that actually the patterns that they're using, the way they're organizing their code is very difficult to actually exploit. And on top of that, you know, by going through and looking at other people's code, helping them strengthen it, helping them improve the way they're writing their code, you know, you're really helping the overall community of Perl programmers and spreading knowledge about security issues, which a lot of Perl developers don't really seem to understand all that well. So right off the bat, what I'm going to be talking about here is an audit instead of a review. In my mind, if I'm reviewing code for security issues, that means that it's internal, and so nobody in public is going to be impacted when I find something and we fix it. When we audit it, on the other hand, that implies that there are people out there using this code, and so the process after we find a vulnerability is quite a bit more complex. Now, almost everything that I'm going to talk about today is kind of based on what I personally have been doing. I've tried to match it up with what OWASP, it's the Open Web Application Security Project. Yeah, that's them. They actually have a lot of documentation on common web vulnerabilities, on you know, including security in the software development lifecycle. And also they have some specific documentation on auditing code for security vulnerabilities. And really their guidelines focus on the more formal approach, which has a few different steps. First, you do a lot of prep work of sort of understanding the application, then you do a model, then you do your audit, and then you generate some metrics off of that. So in the formal approach, when we're prepping, we got to understand the business logic that this application sort of embodies, right? And we also have to understand the execution context, which is, you know, how are the servers organized? What sort of people are going to be interacting with it? You know, is, you know, this system interacting with another system on the back end? You know, that all sort of forms the execution context. So once you have that, you start writing up a threat model. And the OWASP site has, you know, nice guides on how to write this out specifically. They look kind of like user stories that you would see. But basically the threat model is going to define the threat agents. These are the people who are going to want to exploit your application. And then it's going to define the attack surfaces, the ways that they interact with your application to actually exploit it. The possible attacks they're going to do, and then the security controls that you, in developing the application, have to implement to keep them from exploiting it, and then the impacts if those security controls fail. And this is kind of the idea of generating a threat model is really to encourage you to develop layers inside of your application, you know, so that if somebody can break through one layer, they're kind of restricted in what they can actually do. So when it comes to doing the actual audit in the formal model, you're really focusing on the security controls that you defined in that model stage, and looking at how they're implemented in code and what sort of problems there are in those security controls. After you've done that, you go through and assign a rank to each and every vulnerability you found, do some nice graphs for the managers to look at. And then finally you go back and look at what was effective, what was ineffective, you know, both in the model that you generated and in the way that you were auditing it. The formal approach has some big downsides, especially if you're just doing this on the weekend for fun, because there is a lot of upfront work and understanding, everything there is to know about the web app before you actually look at any of the code. It also, with an open source web app, generally you're not going to have somebody available that can give you that deep down understanding as to what every line of code was actually intended to do. So a lot of times you're looking at the behavior of the code and not necessarily the intended behavior of the code. So OWASP also lists another approach to this, and they call it code crawling. And the way that OWASP defines it, code crawling would kind of go along with the formal model. But you can take code crawling as its own way of looking for vulnerabilities in code. And with code crawling, basically you're going to start by looking for the inputs from the user, and then the outputs where it goes to some sort of vulnerable function. It could be SQL statement, it could be sub-process execution, it could be display back to the user. And then you're going to look for connecting up the input, the output, and in between the two, there's nothing actually preventing an injection. So the real advantages to code crawling is that it's very simple to start this way. The vulnerabilities that you see on a code crawling level are really straightforward to demonstrate. There's lots of documentation. If you go to the OWASP site, which I totally recommend you do, they have their top 10 list of different web application attacks. In fact, they have hundreds, if not thousands, of these things documented with examples as to how somebody would exploit your web application this way. The disadvantages, though, are that in a code crawl, it's not real clear exactly which code was responsible for preventing an attack. So if something goes through multiple modules, which one was supposed to filter it out? When they're all integrated together into a single web application, then it doesn't really matter which one, because the web application is vulnerable regardless. When it's a collection of different modules from different authors, then you can get into the finger pointing of, well, my module wasn't supposed to do this, they were supposed to have prevented it. Code crawling also isn't going to pick up just core logic flaws. So if, let's say, your application supports, demo accounts logging into it, it's not going to be really obvious from an input and an output basis that the demo account can, do things that only the admin account should be able to do. And also code crawling, clearly it doesn't, although it finds specific vulnerabilities, it doesn't really give you a good guideline for how to improve the overall software, to make it much stronger. So let's say I've convinced you all, and you all want to go out there and grab some code and look at it. So where exactly should you start? Obviously, anything in the core Perl tree is very important. If you want to look just generally at all CPAN code, the grep CPAN ME is a great site to do that at. If you can formulate a specific vulnerability as a regular expression, you can basically pull them all up here and then start going through and validating them. There's also this list of Perl open source products. There are a couple of different ones. That's one that's been around for a while. Deb tags and code search. Code search is very similar to the Google code search, but it basically has all of the software that's inside of Debian. Debian has a number of Perl web apps, and they have about a third of CPAN. So it's a good place to look also. And of course, SourceForge and GitHub. So to do a code crawl, we can either start with the sources or we can start with the sinks. In some languages, it's really effective to look for combinations of the two. PHP code in particular, you can find tons of vulnerabilities by looking for, posts with an SQL statement. Really, really straightforward to find them that way, and you just intuitively looking at the results, it's obvious that it's vulnerability. With Perl, really looking at the sources is kind of more difficult. A lot of the application dispatch logic varies widely from one web application to the next. So personally, I like to start with the sinks on Perl. So with my personal workflow, I like to go ahead and identify the suspect sinks, then follow the execution of the code all the way back to where the user input whatever ended up at that sink, and then make sure there's nothing in between the two that stops them. Then, bonus points for creating a proof of concept that demonstrates this, very clearly. Even more bonus points if I write a patch for it. And of course, write up lots of documentation and then go and disclose it to the person who wrote the software and all their users. So now this is where it gets really tricky. Disclosure is a crazy, crazy process. Basically every company, every person, they want to handle security vulnerabilities in the code that they wrote in very different ways. As far as like guidelines, there are very few of them out there. MITRE actually has a document for researchers on how to disclose, but it's also very limited in scope. So really the best bet is, if you feel like you can't properly go through all the steps to disclose something, don't even start looking. You're not going to help anybody if you find vulnerabilities and don't carry it all the way through. So with disclosure, there are obviously a lot of approaches. There's the passive-aggressive approach where I find a vulnerability in your software and I don't actually tell you. Instead, I just go on the forums and say what a lousy programmer you are and how insecure your stuff is. Quite common, actually, yes. Then there's the black hat approach. You keep it secret, break into other people's systems. You even have variations on this where instead of keeping it secret and using it yourself, you can sell it to other people. Who all knows who Viewpin is? Anyone? Viewpin? No? Okay, well, yeah, they're a security research company. They actually specifically focus on things that have already been disclosed, so they have CVE numbers assigned. But what they do is they actually weaponize the CVEs, and then they sell them to governments. Supposedly they only sell them to NATO governments. But, yeah, but I mean, there are a lot of people out there. They do pay for vulnerabilities. Even as an individual, you could go to PacketStorm. PacketStorm will pay you for a vulnerability. And as far as I'm aware, PacketStorm doesn't try to weaponize them and use them against people. So there's also the sort of ambush approach, where when you have found a flaw, you go ahead and you document it. You put together a proof of concept, then you go straight to the full disclosure list and dump it all there, without ever giving the person who wrote that software any opportunity to put together how they're going to react to it, to coordinate a reaction. This is very simple and straightforward. A lot of people do it just because they get frustrated with the alternative processes. But definitely people who write software will generally begin to dislike working with you when you do this to them all the time. So really the best approach, but also the most time-consuming, is the responsible full disclosure approach. For me, my way of doing this has sort of evolved over time. What I'm trying to do now is do my initial contacts with whoever wrote the software. So right off the bat, I know I can't open a bug in RT. If I open a bug in RT, everybody can see it, right? As soon as everybody can see it, I figure it's disclosed, whether there's any mitigation strategy out there at all. So the very first thing, you find their security list, you start emailing the author individually, you make sure that they write you back saying, this is a private channel, it's not going to a mailing list. Had that one happen before, Even, I've actually had it happen before where in going through other security teams, they would contact the original author who immediately sent it to a mailing list. Definitely though, with initial contact, and in fact all the stages, you want to specify exactly what time frames you're expecting some sort of response. It doesn't have to be a fix, it just has to be an acknowledgement that the communication was received, that they understand it, that they have some plan. If you don't do this, you don't specify time frames, then you end up sitting there waiting forever, and you know about it, and now we're back into the passive-aggressive approach where it's like, yeah, you don't want to use that, they're not fixing their stuff. But, so definitely, keep specifying time frames. So after you establish initial communications, you do continued communications. A lot of times the upstream author is not going to right off the bat understand exactly what you're talking about. They need some clarification from you. It's actually preferable at this point where they realize they have a vulnerability, they haven't worked up a patch, to go, if the upstream author goes ahead and contacts MITRE, they can get a CVE number privately assigned at this point. So after this, you go into patch development. You go ahead and help them with whatever proposed fix. Very frequently when you report a vulnerability to somebody, they're going to view you as an expert in their code. And a lot of times that's not the case, and you need to make it clear to them that just because it looks to you like it fixes it, that you don't have enough understanding of their code base to really make that judgment. So after the patch is worked up, the upstream author is going to eventually tell people. How they do this is all over the place. Some places are going to coordinate with all the distros that ship out that code. Some of them are just going to post in their forums. Some of them are going to blog about it. Some of them are going to fix it and not really even note it in the changelog that it was a security issue. Kind of regardless of what they do here, if you really feel that it was a security vulnerability, you can go to the OSS-sec list. It's run by the head of the security team from Red Hat. Basically, you post the details there, they'll assign a CVE number to it, and that gets everybody else looking at it as a security issue, regardless of how the upstream author disclosed it. And then finally, if you want to, you can actually release the proof of concept that you created. It's obviously a good idea to wait a little bit after the fixed version is released, so that people don't start attacking those web applications. So again, a lot of the problems with the responsible disclosure approach are that people will basically go silent on you all along the way. Either they won't respond when you send the initial emails and you're not sure whether or not you have a valid email for this person, or you send them the details and then suddenly there's complete silence from them. You know, definitely people will want delays and ask for totally unreasonable ones. I think the longest that I've ever waited for a fix was 4 years. So definitely my personal process in dealing with this has evolved over time to kind of deal with a lot of the problems that I've encountered working with other upstream authors. And it's also very common that when somebody has a security vulnerability in their code, they'll sort of take it personally and try to minimize the consequences of that security vulnerability. They won't document it as a security vulnerability. They won't want to get a CVE number assigned to it. You know, a lot of the things that help everybody else understand that this was a threat to their machines and their code bases, they won't want to take those steps because they feel it makes them look bad. And obviously, yeah, no credit being given. This definitely. I like to get credit when I actually find a vulnerability in somebody's product and go through all the effort of helping them fix it in a responsible way. So it is kind of disappointing when after all that effort they don't mention you, or maybe they even misattribute it. So again, definitely don't start the process of looking for vulnerabilities in other people's code unless you're going to carry it through all the way to the finish.
Is there also the possibility of legal retaliation?
Legal retaliation. Is there a possibility of legal retaliation? Definitely, it's threatened. You know, in some cases it is threatened. I think even with open source software that you're not entirely, you know, risk-free in terms of being threatened, because a lot of the open source software, whether it's Perl or any other language, is actually backed by a company, and that company has a stake in you know, the way that it's done. But I think, you know, so long as you give them every opportunity to fix their stuff in a responsible way, you know, you work with them and aren't actively hostile, the risks of getting sued are pretty minimal. Plus, there are a lot of groups that are interested in, helping defend people if you were sued wrongly.
Maybe I'm misinterpreting some of the stuff I've seen in some news posts, but it seems like just disclosing vulnerability to a company is sometimes enough to take a threat. So I wonder if there's a way to, if you have any tips on realizing just that risk of the case, I mean, like talk to a lawyer first?
Well, there is one good point I haven't made so far. That is that if you find a vulnerability, so let's say I find a vulnerability, in cPanel software, and let's imagine I didn't work for cPanel, but if I found it and I go to their demo machines and I start attacking it, right? That is a crime, If I'm doing the testing on my own machines, then that's fine and dandy. But the second I go to anybody else's machine to actually vet that vulnerability or actively exploit it, it's an attack. There was somebody recently that got in trouble for that. They had broken into somebody's machine, and then after the fact, they're like, "Oh no, I wasn't trying to break into your machine. I was trying to test the vulnerabilities that I thought were there." And that definitely crosses the line. And especially if we're talking about open source code, you have access to the code. You can set up your own test environments, and definitely do that. Don't go and attack their environments because you want to, short circuit the process of actually setting up your own test cases for it. So, okay, so my personal workflow whenever I want to do a code crawl on some code, I go and I get the latest release. Generally, I don't bother actually looking at their Git repos or Mercurial or whatever, just because they tend to be a little harder to find, and it doesn't actually matter because that's not what regular end users are actually dealing with. So I go ahead and check it into Git. Inside my Git macros, I have a bunch of regular expressions to look for different syncs that happen to interest me. And generally, like the list of syncs that I'm looking for are things that, to me, it seems people frequently get wrong. And so there are little subtleties in the way that they work that are frequently misunderstood. So I focus on those at first. I trace the execution backwards and try to find wherever they were securing that sync. Oh, sorry, go ahead.
What sort of role do static analyzers like Covariant play in your work?
In what I'm doing? No, none at all. No. The question was, like, in what I do, what role do static analyzers play? My approach to it, I'm not actually using any static analyzers. I think definitely it's a good approach to take while you're developing code. I mean, even simple ones like Perl Critic are very good. But instead, I'm looking for the things that I think are kind of obscure in the language and prone to being misunderstood by the people who actually implemented the application. Yeah, so anyway, I trace the execution backwards. If I actually find something that's vulnerable, do up a proof of concept. I figured this is essential because I don't want to report something to somebody and it turns out it's not actually vulnerable. There's something I overlooked. So the proof of concept really validates that there was a vulnerability there. If I understand the web application enough and the scope of the problem is limited, then I'll go ahead and write up a patch, send along, then go through the disclosure process. Excuse me. Okay, so this is kind of a look at some of the syncs that I find kind of interesting. Basically, I'm here with the duck one, looking for any sort of use of can, any use of variables as method names. Very frequently, this is on the back end of Perl. There are a lot of quirks with the way this stuff works that people don't anticipate when they write this into their code. And down here, you can see my Git macros to go through the code base looking for these. And for instance, these are some attacks. Obviously, I can, with a method parameter that's specified as a string variable, I can refer to totally unrelated packages that are loaded. I can refer to private methods. Also, if they try to sanitize this by appending onto the end, some versions of Perl will allow you to insert a null byte into it and strip off whatever they did to sanitize it. So this is an example of one of the duck things that I came up with. This was in safe Eval. Basically, There is a duck type call in there, and that's why I started looking at it, although the duck typing wasn't what was actually vulnerable. Although basically this code is avoiding all of Safe's opcode mask to, generate a second duck type call that goes right back into Eval with the opcode mask stripped out. And so inside of Safe, it can entirely get back to unconstrained execution. This one was fixed in Safe 235. I didn't actually follow for a CVE on this one, because really reading the documentation for Safe, it does say that it's not really safe. I don't know exactly what else you use it for if you're running code that you trust to begin with, but I mean, personally, if the upstream author is really insistent that it shouldn't have been capable of doing this, then I'll kind of go with that. I won't fight people too much. This is a second example. This is locale maketext before 123, and basically in maketext you can do these maketext functions that could have been in any package. They don't have to have anything at all to do with maketext. So any other module that's loaded up, you could feed data into it, so long as you can control the maketext format string. And yeah, this was removed from maketext because it just made no sense. Even the comments state it doesn't make any sense. So as a second type of sync, eval, because safe has been said to not actually be safe for containing code, then I consider any use of reval in user-supplied stuff to also be a vulnerability. And let's see, some examples. Okay, yeah, this is another one in maketext. Again, with version 1.2.3, it was assigned to the same CVE. If you actually look at the compile function in maketext, it does a lot of different string processing. One of the things it didn't do was handle backslashes before the comma correctly. And that ended up in the middle of this eval that would just join it all together. This ended up causing problems not only in cPanel, but in FOSSWiki and TWiki, which they have heavily constrained use of maketext, but this still jumped through it. And for some reason, I'm not exactly sure why, but FOSSWiki and TWiki got tagged with CVEs for this, which didn't make any sense to me, because the problem clearly is in locale maketext. Yeah. So another one, any type of exec, so exec system, QX, I really need to add open checks for this, because open is generally exec, yes.
I noticed in this example and in previous one that there are calls to exec that are not fully qualifying all of their paths. Like the Moella example was not qualified.
Oh, well, no, that was my injection, actually. So the backtick, basically, yeah, this is breaking out of basically it's, that eval is putting together a string code, right? And then basically by backslashing before the comma, it breaks out of their string eval, and then I can just do any Perl code I want right there. Yeah. Okay, yeah, so another sync I look for is exec. Any type of exec. This tends to not actually be very common in most web apps. Generally, they're not running all that many sub-processes. Since I work for cPanel, we run a lot of sub-processes, and it's much more important in our context. Oh, and I got my slides messed up. That's beautiful. Okay. Yeah, all right, well, totally messed up my slides. Okay, well, slide not appearing here is another type of sync for IDs. And as far as UID and GID changes, they are very confusing inside of Perl code. Basically, there are 3 IDs that are in operation on on a normal Linux system. You have your effective, your real, and your saved, right? Perl only has variables for 2 of those. And on top of that, when you come to GIDs, your your effective GID also includes your supplemental groups. And the way that you write all this stuff up is quite convoluted. Very frequently people are getting it wrong. So One example of IDs is this code from FCGI spawn. Does everybody know what the vulnerability is here?
Where did the variable group come from? It's interpolated.
Well, yeah. I mean, that's the group name that gets applied to it. But okay, you know what it is, Brian. It is.
Why are you dying if GID is 0?
Well, because it was trying to drop group privileges. You know, it's what.
Basically, you're not changing supplemental groups, so you might still be root, and you might have that supplemental group, and then you just reuse privileges.
Right. That's definitely it. Yeah. Anytime you're doing the effective GID, you have to also set the supplemental groups at that same point. Unless you're going to use POSIX to set them independently. It's very confusing to people until they've actually run into it a few times. You know, but the simple way is instead of having, you know, just be GID here, then it's a string with GID in it, and that wipes out the supplemental groups at the same time. The next one, that one's not fixed. Okay. Yeah, unfortunately, a lot of the ones I wanted to show didn't actually get fixed. So temp is another thing that is insanely confusing to programmers to deal with. Not just Perl programmers, programmers in every language have real difficulties dealing with temp. A lot of developers are used to the idea that the system is entirely locked down. The only access to the system is through the web front end itself. So they write their code with this expectation. The reality, though, is especially if you're doing a CPAN module, you have no idea whether it's on a shared server or a completely secured server. So whenever you're dealing with the temp directory, you have to be very careful about what's going on there because every user on the server can write to it. Yeah. So basically, like for my purposes, anytime anybody is writing to temp, I figure that's suspect and I need to actually look at it. You know. There's one example of temp. This was par packer, yeah. And this one I filed this one in RT because I hadn't really gotten, you know, totally on board with private disclosure first. But in RT he wrote back that basically it was on the sysadmin to secure his module. And then I filed the CVE on it, you know, and then it got fixed. So that's good. Another example, Parallel Fork Manager. This one, in an update to Parallel Fork Manager, it started serializing data from the child processes to the parent ones, and it was writing all this into temp. It was, I think, the script name with the process ID. Obviously, the script name and the process ID are known to everybody on the system, so they could take over that. They could write to whatever files they want. They can inject whatever return values they want back to the original process. That also was fixed very recently. So another sync I find it really interesting is any sort of, you know, any sort of deserialization of data. So any storable loads, any YAML loads, any XML. There are a lot of attacks against these things. XML in particular, OWASP site has, you know, great examples of all the different nastiness you can do with XML, and new ones are being discovered all the time. There was, on OSSSec recently, there was another algorithmic complexity attack against XML, and all the XML parsers had to be updated again. So just generally speaking, if you're taking XML inputs from the outside, you're probably going to be doing it wrong. And definitely if you're taking storable inputs from the outside, you are doing it wrong because storable is, you know, documented as being completely unsafe for use on user-side supplied data. So these are some recent ones. Basically, after the Perl security team added the notice about storable being unsafe, do y'all know what I'm talking about? Probably not. But anyway, yeah, recently the Perl security team added a notice that said, never take storable from an untrusted source. The real obvious things you can do with it, you can do a local file inclusion on any path using storable. You can also, create objects and manipulate their internals so that when they destroy themselves, they're going to do nasty things. So the long and the short is you're not allowed to use storable on anything that the user supplied to you. And there are a bunch of CPAN modules that do exactly that. These three take cookie data, pump it into storable Thaw, and so any web app that was built on top of these is vulnerable as a result. Let's see, I have some more examples of those that are unfortunately not fixed. Okay, another one, I18N. For sprintf and printf, these are traditional format string vulnerabilities. If there's great documentation on this, most of it focuses on the C implementations of printf and sprintf. But basically, if you take any data from the user and use it as the format string in printf or sprintf, then in C, it's arbitrary code execution. They can run code straight through printf. In Perl, you can't run code through it, but you can assign to the variables that are used as arguments. So you can either set them to true or false after they go through printf or sprintf. So basically, like what I'm looking for there is any sort of use of user-supplied format strings. With maketext, as we already pointed out, maketext has a lot of problems. So anybody building on top of maketext, I go and look at their code very carefully. And basically any other type of localization they're doing also needs to be looked at carefully. With localization, most developers are trying to be very generous in supporting everything. They try to accept translations from sources that are not entirely trusted. And so frequently it does bad things in the localization systems. This is a recent one I found in YABB, which is a Perl web forums. Basically, when you're not logged in, you can set a guest language cookie, and then it doesn't sanitize whatever the language you set was. And in other subsystems, you can get files that are based on that language as a path. So here's an example attack. You basically traverse out of that directory, go to another one, stick a null byte on the end, strip off everything after the language. And YABB also allows you to upload files to predictable locations, so it's a complete end-to-end attack on their stuff. This is another translation system one. This was in FOSSWiki and Twiki after they got tagged for the original maketext vulnerabilities. I went back and looked at their code a little further, and FOSSWiki and Twiki actually limit which maketext tags you can use, and so they escape your maketext string wherever it's something that's not within their allowed subset. But their escaping was pretty messed up. You would double the maketext escape sequence and it would go right past their stuff. Obviously there's some other things, like I'm not really looking much at SQL. I do actually go through and look at most open calls, especially 2-argument open calls. By and large, if somebody's writing 2-argument open calls, they have shell command injections in their code, unless they just were either really lucky or really good. I haven't looked very much at excess injections, but I bet you there's plenty of them out there. And so that's really the point of all this is, go and have fun and break into other people's code, and definitely you should learn something in the process. If you take away nothing at all from this other than how difficult it is to disclose, and that you should go to OWASP and read through all of their attack pages, then definitely those are good things to take away. And then finally, there's some links for the OWASP code review guidelines. They have testing guidelines. They have actually tons of stuff on the OWASP site. One other thing I should say about OWASP, if you actually go to the OWASP meetings in your particular city, you'll find that most of the people at OWASP are not actually software developers. They tend to be pen testers instead. And so they're coming at it from a very different perspective. And instead of trying to build secure software, they're trying to, tear holes in it. But it's a very useful thing to meet these people and look at the types of things they're actually trying to accomplish, and the tools that they're using also. For traditional XSS and XSRF stuff, The pen testers have great tools for those things, much better than actually looking at the source code. They can automate, iterating through these things, looking for problems. And definitely there are lots of companies out there that can help you also. So that's all I got. Any questions, comments?
In addition to seeing patterns that indicate problems in code, are there any patterns you've noticed in code that's hard to attack?
Yes, definitely. As far as patterns in code that make it very difficult to attack, the most obvious is that whenever you're taking any input from the user, you limit the scope of it. Rather than looking for bad things that they might feed in, you only look for what would be the good thing. So rather than sanitizing out the double dots and the slashes from what they're feeding into you, you know that this should just be A to Z. That's all it should be. It has to be a number. That's all that you're going to allow through.
Is extra and is not.
Right. Yeah, that is, in fact, code bases that to me seemed like they should have been exploitable. Like I looked at ACT quite a bit, and to be honest, the way that it's written and organized, I really figured I would find an exploit in it, but I didn't, because at every step where I figured I would find one, they were doing that exact type of filtering. Not to say that there are no exploits in ACT. That's just I couldn't find one the way it was written. Yeah. Any other questions or comments?
One minute.
Oh, okay, sorry. Yeah.
I was just curious if there's, you have an audit user integration check
okay. The question was whether whether I have an automated tool to look for these type of vulnerabilities, and I do have a backpan mirror or a backpan and cpan mirror set up, and I have wanted to actually have it go through and automatically flag whenever a new one comes up. The problem though is that for cpan in particular, there's so much code there, and it gets updated so frequently, it'd be very difficult to actually vet all the results that come out of it. With the particular, sync greps that I'm doing, any one Perl module or web app is going to come up with lots and lots of results that I have to go through one by one and actually vet them. I think really, like, in terms of overall improvements, really extending Perl Critic to cover a lot more of this stuff would be a very good thing. And in fact, like a lot of the warnings that come out of Perl Critic, they seem like they're stylistic, but in fact they may indicate that there's something more substantial in the way you're actually writing your code. Yes.
I know that you had mentioned at the beginning you weren't really talking about ways to write secure code, but are there some good resources on where to go to learn the kinds of patterns to do to avoid these kinds of things?
Yes. In fact, so the question was, are there any good resources for, focusing instead of finding vulnerabilities, focus instead on building secure web applications and applications in general. And definitely there are good resources. OWASP actually has a nice book both on integrating security into the software development lifecycle and in structuring your code to be more secure to begin with. A lot of it it's not going to be specific things to do or not to do, but instead just the way that you approach the problems. And that's where it's difficult frequently to get people to change the way that they're working so that they can build more secure software to begin with, is because they have to sort of rethink their starting points a little bit. One interesting thing to note though, like Microsoft and Adobe used to get completely torn up on all the vulnerabilities in their software. I mean, they still do from time to time. But their approach has shifted, so instead of looking for vulnerabilities and mitigating specific vulnerabilities, instead they're trying to build software that has numerous layers in it, so that like the web browsers, whenever they do the end-to-end exploit of Chrome, they have to piece together 20 different vulnerabilities to actually complete it all the way. Which is, it's amazing that people can actually do that, but it's also very unlikely somebody's going to stumble across that, Yes?
If you did have even a few of these vulnerabilities automating your ability to audit them, and could integrate that into CPANs. Even if you couldn't keep up with the onslaught that's being uploaded to CPAN, being able to look at tags on a particular version, I might choose to go back 3 versions off of the bleeding edge just because I knew that it had passed those automated audits. I don't know what all would be involved in integrating all that together, but I would hope that surely you'd have nothing better to do, right?
Yeah. No, so the comment is just that, you know, automating the lookups, even if they can't be vetted, would still be useful information.
Yeah.
And I definitely agree. The flip side of that, though, is that a lot of the vulnerabilities I've reported against CPAN code, they don't get fixed until long after they're actually reported. It's unfortunate, but CPAN has no secure channel to report things, has no, you know, central authority to sort of decide that they're going to fix your software despite, you know, the fact that you don't feel like fixing it. And so there's also no way of tagging it. So like, I can't even, when I open an RT, I can't say that this is a security issue. I can tag it as critical, but that's about all I can do with it. And I mean, realistically, when you go to download a CPAN module, do you open up RT and see how many critical reports it has against it? No, probably not. Some people may very well do this, but by and large, it doesn't seem to be the norm. You know, I think there's a lot more that could be done with CPAN to sort of improve it from this perspective. There is also a lot of really ancient code on CPAN that's written with really ancient conventions, and it's not clear when you go to the search interfaces that this code is vastly out of date and shouldn't be used. In fact, several of the CVEs that I've gotten against CPAN code are against stuff that is entirely unmaintained. So no one will ever fix those. They're just sitting in there documented. You know. I think that we're out of time, right? Yeah. Well, thanks a lot.